the standard deviation by using this equation. Rad is, this would equal to rad of the sample size deviation, the standard deviation of the sample over the sample size of the first one, plus the standard deviation of the second sample, and then the sample size. So, from the equation, we get that we find the standard deviation and the standard deviation for the second one. And then we also find that we have 30 patients for each. So, this is how we do it. We do rad 7.8 squared. Oh, don't forget, you have to square this. So 7.8 squared over 30 plus 8.3 squared over 30. Okay, next we go on our work and we find it with this equation. We do x bar over 1, which is the mean of the first sample. We do x bar 1 minus x bar 2 plus or minus the t-score again times the standard error or the standard deviation. So, we find the t-score using inverse t, and with the equation 1 minus the confidence interval. And so the confidence interval, as we see, is 99%. So we would put 0.99 over 2, and then this would give us, and then you would put this on your calculator. Go to second vars, go to inverse t, and then you would find what this is first. My mistake, I forgot the degree of freedom. And then you would put the degree of freedom, which is 29. Degree of freedom is sample minus 1. So the sample is 30, sample size is 30. You do 30 minus 1, which is 29. So you'd find out what this is first. So 1 minus 0.99. 1 minus 0.99. 1 minus 0.99. Divided by 2. Get 0.005. And then you would find the inverse t of this. So you go to second vars, inverse t, you put in the area first, which is 0.005, comma, then the degree of freedom, which is 29. And then you would get 2.7564 estimated, or rounded to the fourth decimal, and you take out the negative. So, do 2.7564. Okay, so you just put that. That goes with that right there. And so then you find your answer with this. Oh no. And then you find both of the means, which you would find on the equation. So we have 65.2 for the first mean, minus 70.3 for the second mean. Then with all this, 60 parentheses 65.2 minus 70.3 end parentheses plus or minus the t-score of 2.7564 multiplied by the standard error, the standard deviation. This, your answer, you would get negative 10.8319 to 0.6319. And then you get your conclusion. And you would write that we are 99% confident that the interval, we get the 99% confident from the 99% confidence interval that was given to us on the equation. The interval, negative 10.8319 to 0.6319. So we are 99% confident that the interval negative 10.8319 to 0.6319 captures the true difference in the mean pulse rate of patients receiving beta blockers and those who take a placebo. And so that would be our answer.